from the November 2017 grade 11. Question 5. 5.1. Simplify fully. Okay. 90 minus an angle is in the first quadrant. In the first quadrant, sign is positive, but because we have used a 90, sign will change to cos. 180 plus x is in the third quadrant. In the third quadrant, cos is negative. Tan x is sin x over cos x multiplied by cos of x. And whenever we have a negative angle, we're just going to add 360 degrees. So that will become 180 plus x. 180 plus x is in the third quadrant. In the third quadrant, sign is negative. So this takes care of that. I'm going to have negative cos squared x minus, because of that negative, sine squared x. Then we just take out the negative, so that's cos squared x plus sine squared x, and that's just equals to negative 1. 5.2. Prove without the use of a calculator. The left hand side is given as sine 315 degrees multiplied by tan 210 multiplied by sine 190. And then cos 100 degrees multiplied by sine 120. So 360 minus 45 is 315. This is sine 360 minus 45. 180 plus 30, that's 210. And then sine 180 plus a 10. Cos 90 plus 10. And this is sine 180 minus 60. 360 minus is in the fourth quadrant, sine is negative. 180 plus third quadrant, tan is positive there. 180 plus third quadrant, sine is negative. 90 plus is in the second quadrant. In the second quadrant, cos is negative. But because we are using a 90, cos will change to sine. 180 minus second quadrant, sine is positive. This takes care of that. So this is square root 2 over 2 multiplied by 1 over root 3 all over 2 square root 3. Now it's square root 3 over 2. Just double check the other ones. Square root 2 over 2, tan 30, it's 1 over square root 3. Okay. The numerator is going to be negative square root 2 over 2 root 3. And then we're going to divide by square root 3 over 2. So I'm just going to times by 2 over square root 3. This takes care of that. And then I'm left with negative square root 2 square root 3 times square root 3, that's 3, which is equals to the right hand side. 5.3. In the diagram below, R is a point in the first quadrant such that TOR is alpha, RO is extended to P such that OP is equals to 2RO and TOP is equals to beta. It is given that sine of alpha is equals to 3 over 5. So this should be 3 over 5. And since we know that OP should be equal to 2 times RO, that is going to be a 10. That was given there. Okay. Without using a calculator, determine the value of tan A. So OT is going to be equals to 4 units. That will be a 3, 4, 5 right angled triangle. So OT should be equals to 4 units. Of course, you can use the theorem of Pythagoras and then prove that OT is going to be 4 units. But if you know that it's a 3, 4, 5, that's fine as well. So tan of alpha should be equals to opposite over adjacent. 5.3.2. The value of sine beta. This angle, that alpha right there, should be equals to this angle because they are vertically opposite angles. So it means I'll have an alpha there. Okay. So beta should be equals to, from here to here is 180. So that it will be 180 plus that alpha there. So this should be equals to 180 plus the alpha. So it means that beta minus 180 degrees should be equals to alpha. And then I'm just going to introduce sine both sides. Sine beta minus 180 degrees should be equals to sine of alpha. Whenever we have a negative angle, we add 360. So now we're going to have 180 plus beta, which is in the third quadrant. In the third quadrant, sine is negative. Sine of alpha, we are given as 3 over 5. So this means that sine of beta should be equals to negative 3 over 5. So in other words, now we have sine of beta. Okay, 5.3.3. Calculate the coordinates of P. Okay, so let's just give that V, and then we're gonna work on, so remember that sine of 180 degrees plus beta, you remember from here. So this should be equals to 3 over 5, because this is going to be negative sine beta. Okay, so we know that for sine of beta, this should be the opposite. So the opposite in this instance will be VP all over the hypotenuse should be 10. And that's 3 over 5. Still have a negative there. 10 times 3, that's going to be a 30. And then I'm going to end at negative 5 VP. So VP should be equals to 30 divided by negative 5. So I'm getting a minus 6. That's that length there. And then in that triangle, I know that OV squared plus VP squared should be equals to OP squared. And then OV, that's what I'm trying to find. VP, that's minus 6 squared. OP is 10 squared. So OV should be equals to square root of 10 squared minus 6 squared. So I'm getting an 8. So that's a minus 8. Distance cannot be negative. So this implies that from OV, that's an 8, and then VP, that's a 6. So the coordinates of P should be negative 8 is to negative 6. Let's try a different method. Okay. Well, we know that triangle, so I'm going to take the two triangles. I'm going to take triangle OVP, and then I'm also going to take triangle OTR. So O from this first triangle should be equals to the O in the other triangle because they are both equals to alpha. And then V should be equals to T because they are both equals to 90 degrees. So this side, the V should go with the T in that other triangle. And then the P will go with the R. Okay. So now we'll create a ratio. We'll take that over that, and then that over that, then this over that. So it is going to be OP over OR, which is equals to OP over OR. So this is OP over OR, okay? And then OP, I'm making a mistake here. So OP should go with OR, and then VP should go with TR. So it's OP over OR, and then VP goes with TR. And then I'm left with OV, we should go with OT. OP, we do have, it's 10. OR, I do have, it's 5. VP, remember we do not have VP currently. We don't have the VP. So we don't have that. TR, we do have, it's 3. So I'm going to take that. So I'll say OP over OR should be equals to VP all over TR, because triangle OVP is similar to triangle OTR. Yeah. OP, that's a 10. And then OR, that's a 5. VP, I don't have VP, but I do have TR, which is a 3. So it takes me back to what I had there. Therefore, VP should be equals to 6 units. And then you'll be able to find VP or OV easily. Okay. 5.4. Sine of theta minus, okay, let's just do this. The left hand side should be equals to sine theta minus tan theta cos squared theta. So this is cos theta minus 1 plus sine squared theta. This is sine theta minus sine theta over cos theta multiplied by cos squared theta. So I'm not sure what it is that I have to do in the denominator, so I'm just going to keep everything exactly as it is. So this takes care of one of those, so I'm left with only one. So this is sine theta minus sine theta cos theta all over cos theta minus 1 plus sine squared theta. In order for me to get that tan there, I know that in the numerator I must have a sine, and then in the denominator I must have a cos. So I need to work towards eliminating that sine squared there so that I can have a cos in the denominator. So I'm going to take out a factor of sine 1 minus cos theta. Cos theta minus 1. So I'm trying to eliminate that sine squared. Sine squared theta plus cos squared theta is equals to 1. Therefore, sine squared theta should be equals to 1 minus cos squared theta. So this is going to be plus 1 minus cos squared theta. So this is sine theta 1 minus cos theta. Then I'm going to have a cos theta minus cos squared theta. So I'll take out a cos. So 1 minus cos theta. This takes care of that. So I'm left with tan theta, which is equals to the right hand side.